A sledge with brakes has a total mass of 18 kg and is pulled at a constant speed by a rope inclined at 20 degrees above the horizon. The sledge moves a distance of 20 meters on a horizontal surface. The coefficient of kinetic friction between the sledge and surface is 0.500. What is the tension in the rope? Then B. How much work is done by the rope on the sledge? C. What is the mechanical energy loss due to friction? So let's say this is our sledge, like that. Then we have a rope being inclined at 20 degrees there. Now since this rope is being pulled, it means that we have a force which is a tension force in this case. Now one thing that we also have is that we are also having other forces being applied, which is the weight force pulling it downwards, which is mg. We have the upward force, which is perpendicular to the direction of the same sledge. This is the normal force, so it's perpendicular and upward. Then on the other side, since there's friction between the surface, so we have friction force, which is given as the coefficient of kinetic friction multiplied by the normal force, like that. Then since let's say we're moving to the right, here we have that the distance being covered by the sledge is simply 20 meters. So that's the magnitude of the movement, that is in terms of distance, the 20 meters. Now again, looking at these forces that are being applied on this one, is that the normal force and the weight force are vertical forces. Then we have the friction force, which is horizontal. Then the tension in this case is neither on the horizontal nor is it on the vertical axis. So what we're going to find is components, that is in terms of the x and the y. So we're going to have the y component, which will be pointing upwards. This will be the tension, then multiplied by sine of the angle, which is 20. Then the one for the horizontal pointing to the right, this force is tension, then cos of the angle theta. So you are taught to find the tension. So we're going to simply get the net force of forces on the y. Now since we're moving at constant velocity, so mean that our net force is 0. Now these forces that we simply have are the normal force. We have mg. Now since it's in the opposite direction, so it becomes a negative. Then this gives us a 0. Oh, sorry, we also have another force there, which is an upward force, now which is a component of the tension, which is positive t sine 20. Now we can set this equal to 0 since we are moving at constant velocity. Now in this case, we're going to solve for the normal force, make it substitute the formula. So we're going to have the normal force to be equal to, the rest will go to the right, so we're going to have positive mg minus t sine 20 degrees. So this is what we get on the vertical axis. Now let's go to the horizontal. We have that also here the net force is equals to 0. So on the horizontal surface, on the horizontal axis, sorry, there are only two forces being applied, which is the tension force multiplied by cos theta, which is positive, and the friction force, which is negative. So we're going to say t cos theta, then minus the friction force, which is given as mu, then the normal force. This is also set to be equal to 0. Now we'll write as tension cos theta, then we'll write mu. What is the normal force? We'll substitute what we have there in our first equation, which is mg minus t sine 20. This is definitely equal to 0. Now from here, we're going to get t cos theta. Then we're going to multiply the mu with what is inside parentheses. This will be mg, then plus mu, which is the coefficient of kinetic friction, times t sine 20 equal to 0. Now here, if you look at this, only two terms of tension, so that one will be taken to the right. So we're going to get T cos theta plus mu T sine 20. So this would be equal to positive mu mg. Okay, now here we can factorize T such that we remain with cos theta plus mu sine theta, which is just the same as 20 there, then equal to mu mg. I'm going to divide both sides by cos theta plus mu sine 20 so that we remain with the tension force that one I'm looking for. Even on the right as well. So the common terms that we have on the left will cancel, leaving us with the tension to be equal to mu mg cos theta plus mu sine theta, which is a 20. Now let's do our substitution. So it will be mu, which is 0.500, to multiply with the mass, which is 18 kgs as well given in the question, then multiply by acceleration due to gravity is 9.8. Then we divide with cos of the angle, which is cos 20. Then we add with mu, which is 0.500, to multiply with sine 20. When we do our calculations, we get our tension to be equal to 79.4 newtons as the tension force. So this is the answer to part A. From here now we go to part B. That's what we are taught to find in part B. In part B, we are taught to find the work done by the rope on the sledge, meaning that we are finding the work done by the tension. Now work done is simply equal to, so this is, we'll find the work done by the tension force. So what you need to remember is that work done is simply equal to the product of the force, then cos of the angle, depending on which angle it is, then multiplied by the distance. Now in this case, the force that we're looking at is the tension force, so it will just be 79 for force, which is our tension, 0.4 to multiply with cos of the angle 20 degrees, multiplied by the distance that we are given, which is a 20. Now when you do our mathematics, you are just going to get the work done by tension to be equal to 1492 joules. So this is the answer to part B. We go to part C. Part C, we are taught to find what? So what is the mechanical energy loss by friction? So this is work done by friction. So we're going to just find the work done by friction. So let's go back to our free body diagram. So this friction is the same as the other force that is on the left, which is a component of the tension. So that work done by friction will just be equal to negative work done by the tension force. So here to find the work done by friction, we're just going to get the same value for the tension, just that we attach a negative in this case. So this is our answer.